This is a video recording for Lab 1, and I want to show you some of the steps as I perform them, and you should perform them independently. I also recommend that you go through some of the steps multiple times just so you get the hang of it. Sometimes doing it once is not enough. I'm at the course website. My voice is bad, so hang with me. And I assume that you've installed the software, that you've looked at the tutorial, and that now we're going to start the icebreaker. And upon completing this tab, you should be able to, this lab, you should be able to perform these steps that you see here. I'm going to do part A, and I hope to do it quickly. First thing, your Unix directory, your Unix account has directories. If you want to see the directories in your Unix account, the command that you type is LSD. Not the dope, not the drug. And the directories are indicated by a slash on the end. In my directory, I have 1,000,000 of these. You only have 2 or 3. One directory has been designated for you to do your programming. And that directory is called COP, where is it? 3014C. So we need to move to that directory. And how do we do that? From the Unix, you recall that I can say change directory to one of my subdirectories, COP. In Unix, if you hit the tab, sometimes it can complete what you're typing. So it saves you from mistyping things. Inside this directory, it's blank. I've made it blank, so because yours is likely to be blank also. So now let's do the step 2. Step 2 says get executable programs, say hello.run and add4.run from the public repository and execute them in Unix. I've shown you the commands here. So the first command, I may as well just copy this. Copy it, paste it. And when I do that, I see that a file called sayhello.run is now in my directory. Alright? The star on the end is not part of the name. It just indicates that this file can be executed. Notice here that when I got the file from the repository, I'm making a copy of the file that is in the repository, placing a copy into my directory. This arrow tells you that something is coming into your directory. Alright, what's the next step? It says if I want to run it, the way that you run any file that can be executed is to say dot slash, and then give the name of the file. Say hello.run. And what does the program do? Well, it produces the line that says hello friend, but it also produces a line before it and a line after it, and these lines identify the author of the program. So when you write your programs, you should produce 2 copyright lines, one at the beginning and one at the end. Your turn. I'm not going to do your turn now. You need to do the same thing for add4.run. That's step 2. Step 3 says get a source program. In C++, a source program is a program that you can look at. Let me show you what happens if I try to look at what's in sayhello.run. You can see what's in a file by typing in 2 commands. One command is more, and the other command is cat, C-A-T. So if I say more sayhello.run, what do I get? Oh brother, I get garbage. Did you notice that? I get a whole bunch of garbage. So it's what's called a binary file. It's not meant for human eyes. It has meaning to the computer but not to a person. So a source file is the form of the program that can be read by a human. And it looks like the code that you would see in your textbook or in the notes. So let's get the source code. How do I get the source code from the public repository? The name of the file is add3.cpp. Where is it? In the public repository. How do we get it out? We copy it. So the command is cp which is the source of the file. We're going to copy it, and the name of the file is add3.cpp. So notice that with the ls command, it tells me I have 2 files now in my directory. Okay? Now, the step that I want to do here is I want to compile it. But first, let's look at it. I said I can say more add3.cpp, and all of a sudden this makes sense. You can read this, right? And this is what a program looks like. The top part of the program is identifying the program itself. The file name, what assignment we're doing, a due date, purpose, and the author. Notice the author is given in the form of your Unix login followed by your first name and last name. There are different sections of the program that we will talk about later, but we said in class that a program is like algebra, which means we got to have variables. Variables are names for values that we manipulate in the program. All right. So we don't really need to try to understand this yet, because when we run this, we will see how it behaves, and we can look at how it behaves and how it's written to learn some important lessons. So what are we to do? We're to compile this. To compile a program, the program name is G++. And it must be followed by the name of the source file. A source file is indicated, ends in the prefix, ends in the extension .cpp. So I can compile this, add3.cpp, and it produces a binary file. And what is it? Well, it's this file called a.out. Strange name, isn't it? So that we can compile it a different way and control the name of the resulting file. So we can say we want to call this add3.run. So I have 2 versions of the program now. I have the version that's the source code that I can read, and I have the version that I can execute. The one that I execute, I cannot see it because it's just garbage. So let's execute it. How do we execute any program? / and the name of the program, the name of the executable, in this case add3.run. And when we do that, it says enter 3 values, and we see that the program reads 3 values. It shows you each of the values, and it shows you the sum. Notice also you have the copyright before and the copyright after. All right. So I think I have shown you in the secure shell you can recall commands. So I can go back through my commands and see what I have done. So if I want to repeat a command, I can back arrow and recall commands. I'm going to show you a little trick. There's also a command called history that tells you all the commands you've done. So if I want to repeat command 13, I can repeat it by saying ! 13. And it will repeat a command. I don't have to retype it, and so forth. All right. Now, what's the last part? I want to submit the executable program add.run. How do we do that? Well, this is the command. This is the command. Notice that to submit, I must identify the assignment. The assignment we're working on now is Lab1, and I must give a file that I want to submit. Before submitting, though, let's look at something. Let's look at the CS status. I'm going to say add. When you do this, I won't do it because I have files in my repository. If you do that, you will see that you don't have files in your repository yet. After you submit and do the same command, you will see those files. So let's go ahead and submit. And it says, it says this is not an ASCII file. It's a binary file, and you cannot submit binary. If you submit a binary file the second time, you must remove the first one. You may not get this message because you haven't submitted yours. And now I can see that the file add3.run has left my directory and has gone into the submission repository. when it goes into the submission repository, its name is changed. Notice it's the name I gave it followed by my login. All right. So if I were to now do CS status add 3 dot, I would just say add 3 dot. I will see add 3 dot run is in the repository. And you will see something similar. It will say add 3 dot run followed by your login. Okay, I think with that we have done part A. So we're going to stop the recording now.